So in this video, I'm going to be covering section 10-2, linear regression. So the pre-skill for this section is you have to be familiar with the equation of a line. So this is something that you learn in algebra or pre-algebra. So recall from algebra or pre-algebra that the equation of a line can be written in the following form. So in algebra, this was the form. This is what we call the slope-intercept form. So we have y equals mx plus b, where m and b are values that we typically know. They're given values, and the value m is the slope, and the y-intercept is b. Right? Again, b along with the sign here is the y-intercept. So for example, like in this example right here, the slope is 2.1, right? And then the y-intercept is positive 5.3. Okay, so in statistics, very similar in this chapter, in statistics, we write the equation in the following form, y equals a plus bx. So typically what you find in statistics is that the x term, right? So here the x term came first. The x term is the second term instead, right? And sometimes they use a for the y-intercept and b for the slope, and sometimes they switch it around. But just know that the value in front of the number or the value in front of x is always your slope. So here's your slope here, the value in front of x. Here's your slope, right? B is your slope here, the value that's in front of x, right? So the value in front of x is always your slope. All right. Another thing to be, that's good to know is a line that's going from like a line that looks like this has a positive slope, right? And a line that goes down like this has a negative slope. So for the pre-skill problem, all you're doing here is just identifying the slope and the y-intercept for each equation. So let me go ahead and do the first two, and I'll let you guys do 3 and 4. So for for problem number 1, the slope, again, the slope is always the number in front of the x. So in this case, the number in front of the x is positive 13.02, right? We always got to take the sign here into account. So this is 13.02. And then the y-intercept is the other value. So this value right here, positive 0.238. Okay, let's take a look at number 2. So problem number 2, the slope, again, the slope is always the number in front of the x. So here's x, right? So the number in front of x is negative 1.516. And the y-intercept is the other number. So in this case, positive 6.4. All right, so for 3 and 4, again, you always want to see where x is, right? Locate the x, and then the number in front of x is your slope. So in this case, again, always take the sign into account. Negative 2.104 is the slope, and then positive 0.045 is the y-intercept. And then for this one, again, here's x. The slope is negative 0.618, and the y-intercept is negative 4.27. Okay, so in the last section, we learned how to determine if there is significant linear correlation between two variables. In this section, we're going to learn how to find the equation of the line that best fits the data values. And then we're going to use that to predict y values when appropriate. So we have a name for that line. So we have this scatter plot, and the line that best fits these points on the scatter plot, we call that the regression line. So the regression line is the line of best fit, is a line that best fits the scatter plot of a paired sample data. There should be a quotation right here. All right, so the regression and then the equation that describes the regression line is called the regression equation. So you're going to hear me say that a lot. You're going to hear me say regression line and regression equation throughout this video. And the The regression line is the line itself, and the regression equation is the equation that describes the line, right? So the red line here is the regression line. The equation is given right here. So in this chapter, we need to know how to calculate this or find this regression line or regression equation rather, and then we're going to possibly use it to predict values, right? So if we have this line, this equation of the line, like we can, if we're given an x value, so in this case we have weight versus height. If we're given, say, like a weight of, like, let's say somebody who is 88 pounds or kilograms here rather, then we can plug in that value in here for our x, and possibly we can figure out their height based off of a weight. So that's the idea of this chapter. But I want to say, kind of give you guys a warning as well. So sometimes we're going to use this equation to predict y values, but sometimes we're not. And I'll go into more detail in a bit. So the function we're going to use in this chapter is called linreg, or this section rather, is linreg. And before you can use this function linreg, for some reason, some calculators, some TI-84 and sometimes TI-83 calculators does not have a certain thing turned on. So please just go ahead and walk through the steps of doing what I'm going to do here to turn on that function. And you only have to do it one time. You don't ever have to do it again after this one time. So what you want to do is you want to access the catalog. So the catalog is right above the 0. You're going to see catalog in blue. So to access that, we're going to press second 0. And then you're going to go all the way down to diagnostic on. So just keep on going until you get to diagnostic on. All right, so diagnostic on, press enter until it says done, and you're good. You only have to do it one time, and you don't have to ever do it again. And that will ensure that your linreg is going to work properly. Otherwise, it may not work properly. Okay, so let's go ahead and look at the following. So here are the steps, or the way we're going to our decision to predicting y values. So the question you have to ask first. So if you guys remember, I had mentioned earlier that sometimes we're going to use this equation to predict y values. Sometimes we can't. And the way you make that decision is you have to ask yourself is there significant linear correlation between the two variables? If it's yes, if there is linear correlation, then we're able to use the regression equation to predict the y values. If it's no, if there's not linear correlation, or if there's not a significant linear correlation, right? That's if the absolute value of r is less than the critical value. Then we have to use y bar, which is the means of the y's, as our best predictor. And I'll go through a problem like this so you guys understand how to do it. So we looked at this example in the last section, last video. So we have that ice cream parlor who's interested in whether there is a relationship between temperature and cells, right? So our x value is the temperature, our y value is the cells, and we have the following data set. So the first question says, find the equation of the regression line. Use a significance level of alpha equals 0.05. Actually, I meant to put this statement down here. We don't need this significance level to find the regression line, but let me show you the steps to find the regression line. So step 1, you're going to input the x list into L1, and then input the y values into L2. So I had already done that already. So if we're going to go to stat and then edit, I already did that. Step 2, to find the regression line, we're going to use the function linreg. So we're going to do that by going to stat and then going to calc. When you go to calc, there are two linreg functions. There's this one, linreg ax plus b. And there is this one, ln reg a plus bx. So I recommend you use this one because this is the format you're going to see the equation, the linear equation in this format in statistics, right? So this is the format in statistics that you're going to see most often. So a plus bx, where the b here is the slope, right? The number in front of x is a slope. So go ahead and get into that habit of using the second one, this ln reg ax plus b. I'm sorry, a plus bx. Okay, so the x list is in L1. The y list is in L2. That looks good. Frequency list, we're not going to use that. Just leave it blank. Stored reg equation, we're going to leave that blank as well. So if you do everything correct, all you got to do is go down to calculate and do that. So let's see. So their equation in the a plus bx form is the following. So we have y equals, so a is negative 675.9. So again, I'm rounding here to 1 decimal spot, plus, right? So plus b. B is the slope. So b is 16.4 x. So this is the regression equation. So this is, if we were to plot all of these points, if we were to plot these points on an ordered, on a scatter plot, this would be the line of best fit. This would be the line that best fits these points. So I plotted the scatter plot of these points on using my TI-84, and this is the scatter plot. And this line right here, if I graph this line, it would be the line of best fit right there. So to graph this, I'll just show you briefly. What you want to do is you want to go to stat plot. So you're going to press second and this button right here, y equals. And you're going to want to make sure that your plot 1 is on. So you're going to press enter and make sure it's on. And then also that this is selected. This one, this is the first one. This is the scatter plot. So these other ones, make sure those are not selected. Make sure the first one here is selected. L1 and L2 looks good. You can choose either one of these marks, but I just chose this squared one. So once you have that, that's good. I'm just going to press second mode to quit. And then from there, we're going to press zoom. So press zoom, and you're going to go down to zoom stat. So zoom stat, press enter, and that's how you get the scatter plot. All right, so question B says, find the best predicted value for the amount of cells given that the temperature for a particular day is 90 degrees Fahrenheit. So this is asking you to find, predict the Y value, right? The Y value is the cells, given that the temperature, which is our X, is 90 degrees. So we have to make a determination. So we want to predict, essentially, when X equals 90, what is Y, right? Again, Y is the cells. We can possibly use this, but sometimes you're not able to use it. If the linear correlation is not strong enough, you can't use it. It's not a good predictor. So the first step is you have to determine whether there is a significant linear correlation. So that's the first step you need to know. You have to ask yourself, is there a significant linear correlation? So in order to determine that, right, is there a significant linear correlation between the two variables? You have to figure out what R is and then figure out what the critical value is and compare the two. So if R is greater than the critical value, again, the absolute value of both, then yes, and you're going to input the X into the regression equation. If it's not, then you're going to, the best predictive value is the average or the means of the Y. All right. So here, for this problem, we know what R is. When we use ln reg gives us, calculates the value of R as well. So press enter, and we get that R is equal to, so here's R, 0.953. And now we need to figure out what the critical value is. So the critical value, again, if you watched the last video, we need to know two things. We need to know what N is. We need to know what alpha is. So alpha is right here, 0.05. and n is 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, n in this chapter, or this chapter, is the number of pairs of data. So there's 12 pairs. And to get the critical value, we're going to use this table. Right? So n was 12, and alpha was 0.05, which means there's our critical value, 0.576. So that's 0.576. So R is definitely bigger, right? So the absolute value of R is greater than the critical value, which means that, yes, there is a significant linear correlation, which means to best predict the X value when X is 90 degrees, right? When the temperature is 90 degrees, we can use the regression equation. So what does that mean? We're just going to substitute this 90 into the equation right here. So we get the following. We get y equals negative 675.9 plus 16.4 times x. So in this case, x is 90. So I'm just going to plug in this 90 into the equation. All right, so I'm going to punch it into the calculator. So we're going to get negative. So negative sign is right below the 3. So negative 675.9 plus 16.4. And then I can open up parentheses, put 90 in there, close parentheses. So we get $800.1, right? So what this tells us is that when the temperature is 90 degrees, our cells, we're going to predict our cells to be 810 cents. Okay, so now what if there wasn't a significant linear correlation? So again, let's pretend we get the following. Let's pretend that we get, write that a little nicer. So let's pretend that we get, let's just say that R was, and again, let's just pretend that R was like 0.495, and then the critical value was 0.576. So in that case, R is less than the critical value, which means that there's no significant linear correlation. There's not significant linear correlation. So in that case, what do? So the diagram here says if there's not a significant linear correlation, right, with R, the absolute value of R is less than the absolute value of the critical value, then the average, the means of the y's, is our best. We're going to use that as our best predicted values. So now how do I find y bar, the average of the y's? Well, I can add these values up, right? Here's the y list. I can add these values up and then divide by 12, which is the number of values. I can do that. Or we have a function that can do that on our calculator. So that function is 1var stat, right? If you guys recall, 1var stats. So let me just go ahead and put this in our notes as well. So we're going to use y bar, and for y bar, we're going to use 1var's stat. 1var stat on L2. That's where we put our y list. Our y list we input into L2. So we're going to go here. We're going to press stat and then go to calc, right? 1var stats is our very first function that we use in this class, right? So for a list, we're going to put L2 because that's where we store the y's, right? So second 2. Frequency list, we're going to leave blank and we're just going to calculate. And then this x bar is actually our y bar. And our answer, our best predicted value, would be $403.50. Again, we're pretending, or hypothetically speaking, if this was the R value that we got and this was a critical value, to where there's not a significant, we conclude that there's not significant linear correlation, this would be your answer in this alternate reality, right? But really our answer here, the best predicted value, made us conclude to use the regression equation to best predict the value for 90 degrees when x is equal to 90, and we plugged it in here. But this is like if there wasn't linear correlation. Okay, so that concludes this section. Again, if you have any trouble, always please reach out to me.